Hey everybody, Happy New Year. It's Troy from Flying Squirrel. Hey, I'm doing something a little different. A couple of weeks ago, I got into a conversation with Yankee over at Yankee's Outdoor Adventures. He's linked here. Talking about stargazing and astronomy, and I happened to mention to him, hey, I do a blog, and one of the things on my blog every week, I talk about observational astronomy that you can do in your backyard with an eye towards understanding what's going on from a sense of establishing time and place. Being able to navigate, understanding seasonal changes, what's going on with tides, what's the moon going to be doing, all that kind of stuff that really kind of enhances the outdoor experience. It helps you tell time even. I mean, it's that kind of thing. So he asked, well, are you doing anything on YouTube with that? And I said, well, no, I'm not sure some of this would lend itself to a YouTube environment, but hey, let's give it a try. A lot of what I talk about here, and the reason I do it weekly, is that some of this stuff is like now. It's an event that happens at a particular time. A lot of it is more general. I have a background in this. It's not obvious with any of my other stuff, but I'm actually an engineer, aerospace, amateur astronomer, and orbital mechanics and astrophysics and all that kind of fun stuff. So we'll do a little bit of the science, but only to the degree that it kind of helps visualize and understand what's really going on. So this week, there's a lot of things that are happening at discrete times this week to kick off 2018. We're going to talk supermoons. The Earth is at perihelion. We're going to meteor shower and very interesting planetary conjunction. So if any of that sounds interesting to you, hang on and we'll see how this works out. Okay, so first off, New Year's Day. Happy New Year. Woohoo! New Year's Day, we're going to have our first full moon of the year, and we're going to have a supermoon.
Supermoon.
What the heck is a supermoon? Everybody's all excited about that. Well, to understand what a supermoon is, first you have to understand that orbits are not circular. They're ellipses, if you remember your high school geometry. The orbited body, let's say the Earth, is at one focus of the ellipse, and the thing that orbits it is the moon out here. It's close on one side and far on the other, right? It does not go around in a circle. In any orbit, when we have that ellipse, this close approach is called a periapsis. Far is called an apoapsis. So in a given orbit, we might have a periapsis over here and then an apoapsis out over here, right? In terms of the Earth, it's a perigee. Geology, geography, it's Earth-centric. Well, that's what the moon's doing. It will be at perigee tomorrow during its full moon. If you happen to be in a situation where you're on this close side and the sun happens to be that way so that it is full and close, you get a supermoon. That's all it is.
Supermoon.
If it's far, well, it's not so super. Close, it is super. Can you tell? I mean, it's 7%, up to 7% bigger, which means it's reflecting 16% more light. So, you know, if you picture something that's a meter or so long, we're talking about a difference of that. So, yeah, I mean, that could be noticeable, but on the size of your thumb, you really have to be in tune with what the moon normally looks like.
Supermoon.
That's happening on Monday. Keep in mind, though, since it's the first, we're going to have another full moon in January, which means we're kicking off the year with a blue moon, a full moon. It's going to be another supermoon, and oh, by the way, there's going to be an eclipse that night, so we'll have a blood red moon. So it'll be a super blue red blood moon at the end of January. More on that as we get closer to it. Earth on Tuesday will be at perihelion, which is its closest approach to the sun. Counterintuitive, I know it's dead of winter, it's cold, particularly here in the east, but we're at the closest point to the sun, which means the sun actually probably looks a little bigger right now too. Can we tell? Again, no. But if you think of eclipses and the difference between a total eclipse and an annular eclipse and all of that, these little differences start to actually become apparent. So perihelion, one of the interesting things about perihelion is when you're at your closest approach, that's also the point in your orbit in which you're moving the fastest. Tuesday will actually be our longest day, noon to noon, if you reference where the sun is in the sky, of the year. And the reason for that is we're moving past the sun so quick. To the whiteboard. If we use a little reference point on this rotating Earth, you'll notice here we're pointing straight up, straight towards the sun. Well, during the course of a day, and it does one orbit, you come back around to where that particular point is where it was, and you're no longer pointing at the sun again, because you've moved past the sun. The Earth has to rotate just a little bit more for that point to be pointing back at the sun. What does that equate to? About 7 seconds more than average. Our day will be 7 seconds longer than average. But hey, again, if I had accurate timekeeping, that's something I would notice, and I'd start to piece together kind of the mechanics of the universe. So, just a point of interest. Perihelion is January 2nd. Next item on the list, January 3rd, middle of the night, is the peak for the first significant meteor shower of the year, the Quadrantids. I won't go into its name for this particular instance because, frankly, it's not going to be a very good shower. The moon, as we just discussed, is going to be so close to full, it'll be washing out the entire sky. There's not going to be a lot of dark skies around. So the bright meteors you'll see, normally this has up to 120 an hour, but we're probably not going to see most of them because they're all going to be washed out by the moon. In any case, though, if you're out Wednesday night late, take a few moments, look up. You might see one. That's going on this week. Last but not least, some planets. I'm not a morning person. I don't normally advocate spending a lot of time or effort to get up early in the morning, but this week is actually kind of worth it. There aren't many planets in our evening skies right now. In fact, Uranus is really the only one you can see. In the morning, though, Mercury reaches its elongation on Monday, which means it's as farthest away from the sun from our perspective. You picture, if this is the sun, you picture Mercury in here really tight, really going fast. You can't see it for most of its orbit because there's the sun is either blinding you or literally blocking it. But when it gets out here towards the end, you have a chance. Monday, it's at its maximum elongation, which means you've got the most time between it coming above the horizon and sunrise to see it. So it's visible pretty much all week, and surprisingly bright for such a small little thing. The cool thing, though, is Mars and Jupiter are together in the morning sky, and next Saturday, Jupiter and Mars will be so close to each other that with a telescope of medium power, you'll be able to see both of them in the same view. Jupiter is going to be zipping by it this week. The relative motion is going to be extremely apparent. And in fact, I put together this little stop motion from stills from an app called Stellarium. It's kind of a virtual planetarium that shows you day over day that motion. Here's the weird thing about this. I mean, take another look at this. You notice Mercury is going down day over day toward the horizon. Mars is pretty much standing still. Jupiter is moving right by. This caused all kinds of problems back in the ancient days when we were trying to figure out what in the world these things are, how are they moving. The word planet comes from the Greek of wandering. It's confusing. Everything's moving in opposite directions. Well, here's how you have to visualize that. Understand, here's where we kind of are in the solar system right now. If you're looking down on top of the north pole of the solar system, everything moves counterclockwise. So from your perspective, everything's doing like this. Not only is everything doing like that, but it's also rotating that same direction as it goes around. If you kind of get that mental image in your mind, it helps to kind of understand our relative positions. Abstract yourself and kind of look at the world from outside the solar system with Earth in it and understanding everything else. This all kind of falls into place. So understand, if you're seeing planets on the morning side of the sun, you're all, including yourself, including Earth, everything is running that way, towards the sun. Okay, you're chasing it. The other thing that you need to understand is the closer you are to the sun, the faster you've got to move to keep from falling into it, right? So inner planets orbit quicker than outer planets. General rule. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Slower the farther you go out, and Mercury is a little speed demon in the middle. If we're looking at the morning sky and the sun is about to rise, Mercury is running away from us and behind the sun, so it's actually running down towards the sun. Mars and Jupiter, picture it like this, and I've tried to do this little stop motion here to help explain it. Picture yourself in the passing lane on a highway. You're moving faster than the car in the right lane, in this case Mars. and both of you are moving faster than, say, a slow train on the shoulder. What happens is, relatively speaking, Mars, that guy in the slow lane, isn't moving very fast at all, and you're both zipping by the train. What it shows is the train is moving in the opposite direction. That's what we're seeing here. Now, both Jupiter and Mars, as I showed in the little solar system diagram, both of them are kind of looking past the sun and seeing those two planets on the opposite side of the solar system. But they're moving in the same direction we are. We're catching up. We're catching Mars slowly. We're catching Jupiter a little bit quicker because it's so much slower. Jupiter's getting higher and higher and higher in the sky, moving further west. And by the way, before you know it, it'll be visible in the evening sky, and you won't have to get up at the crack of dawn to see it. So those are the things. Again, having planets this close together, this conjunction, is really kind of cool. It's really kind of unique. But if you see it night over night and witness that movement, it becomes very aware that, you know, hey, things are pretty dynamic. Things are moving a lot, and it's not just the moon, right? These planets are all out there moving. So I hope you find this interesting. I hope you get a chance to get out there this week and see any of this. Let me know if it's interesting at all, if I should continue this. Again, with a week-over-week thing, I don't know that I can do this, but we'll give it a shot. And again, thanks to Yankee for the suggestion. Next week, I'll maybe spend a little bit more time talking about just what's visible in the winter sky and how you can kind of leapfrog from constellation to constellation and kind of understand what's there and sort of start to get that mental landscape and mental map of the stars embedded in your head. It really does become useful. Anyway, let me know, and Happy New Year, everybody. I'll see you in 2018. Later.
Supermoon.